Hello, this is Jeffrey Fox here with a second lesson on web search and text mining, going into a little bit more practical details. Previous lesson was largely the basic theory. And of course, we remember the whole purpose of this class, which is using clouds. Those are the clouds that crawl the web and the clouds that do the query searching when you type things into the web. And they're processing truly big data in this case. They're running the analytics programs, some of which we did last lesson. And we're doing X informatics, where here X is what I sometimes call lifestyle informatics, because sort of one's lifestyles, the various things such as social networking and etc., which just define the way we live, and that's what this application is key to. And here are all the various X informatics this class does, and let's just have a review of the different aspects of data analytics needed in web search. So we have here 8 sort of components of web data analytics. One is getting the digital data. It's scanned in from books or it comes from the web. And as a part of that, you have to crawl the web. And crawling the web is quite tiresome, but I think it's a largely solved problem where you just need enough diligence and computers and disks to send out the crawlers and store the results. After getting the web data, wherever it's from, we have to pre-process it to get searchable things. These are the so-called terms, which are basically process words and possibly the positions of the word in the document, so you can search for phrases effectively. Then we'll have to form the inverted index, which we'll discuss a bit more this time. And the inverted index maps words to documents. Then we have an area which is a lot of more recent work has been done, which is not just finding the pages that match your search, but finding their relevance. And that's where PageRank is one example of a relevance methodology. Then there is a lot of important technology, important at least for the search engine people, because this is how they get their money for advertising. And then there's what I call reverse engineering, namely websites trying to make certain that they put the right things on their websites and in their HTML so that the search engines rank their website highly. And then there's the search engines trying to stop such reverse engineering and only get back things that are really important, not things that the website tried to make important. If you look at everything except 4, it is sort of trivially parallel because every document can be processed independently. PageRank is not is parallel, but not trivially parallel in that PageRank involves iterations over many sites which are linked together because you're iterating of a formula which involves going to a given site and then looking at all the places it points to. Another important feature of this field is studying the structure of the internet. We will come back to something we did in the previous lecture, the bow tie structure. And of course, the social networking, something which we will not discuss in this lesson, is important with its linkages between people, and of course, the linkages between people and pages. This is an area where there's a lot of research. The linking of people and pages is sort of more connected with the recommender engine work we did earlier in the class than it is with the search, because it's more connected with relating things together, which is what recommending engines do. we do have some important ways of trying to link documents together, because when you do a query, such as into data science, you want to try to get lots of documents into data science. And then there's some technology which cluster data science documents together, or find a secret implied relevance of a document to data science with so-called latent factor analysis or topic models. This is used in practice, but it's not totally clear, I think, what works, because the people who use it don't tell you what works. I remind you of something we discussed at the end of the last lesson, which is that there is a well-known mathematics of probability frequency distributions, but actually that gets used by the Bayes principle as a mathematics of belief or relevance, because that's what you want. You want to try to bring back pages that the user wants, not pages which satisfy some frequency criteria.